Hello everyone, welcome to online lecture series on feedback amplifiers. This is the third video. Let me just revise what we had done for the last video. We had seen these feedback configurations, how they are related to the amplifiers that we had studied in video 1. Okay, now over here there are some circuits which are present. Those are purely for amplifiers without feedback. Okay, there is no feedback which is present over here. Is there any feedback? Just have a look. Okay, for feedback to be present, how do I identify? There should be some beta value. Okay, like for example this is giving V out, so Vf should be there somewhere. Is there a Vf voltage, feedback voltage? No, it's not there. Then what we had studied for video 2, we had seen that this is an amplifier without feedback. Now if at all I want to use an amplifier with feedback, which feedback configuration will suit the best for this particular circuit? That's what we had seen. Okay, just after having this particular circuit, what we had seen was, looking at the input side and at the output side, I came to know that I can use a voltage series feedback. Okay, and also we commented on the input impedance and output impedance with respect to the series feedback connection, shunt feedback connection, voltage feedback connection and current feedback connection. Okay, so mind you all, these are the circuits only with respect to amplifiers without any feedback. Okay, there is no feedback, but I wanted to tell you all that which is the feedback configuration out of those 4 which we had seen, 4 topologies. Out of those 4, which is the best suited for these amplifiers? Okay, I hope this is clear to you all. This is what I wanted to tell you all. Now say for example I have a voltage amplifier over here. Okay, then which was the feedback configuration? Voltage series feedback configuration. So this is the voltage series feedback configuration, right? So along with the voltage amplifier, I'm going to use voltage series feedback if at all I want to introduce feedback for this particular amplifier. Similarly, go to the current amplifier. For current amplifier, current shunt feedback. Okay, we had seen this. Where is that? Okay, for current amplifier it is current shunt feedback. Okay, similarly transconductance amplifier, it is current series feedback. Over here have a look, transconductance amplifier, it is current series feedback. Okay, and trans resistance amplifier, it is voltage shunt feedback. Okay, so whichever circuits you all had seen over here, those are without feedback, but we were trying to figure out which is the best feedback configuration that can be used for these particular circuits. Okay, so I hope this is clear to you all. Another thing that we had seen in the last video was negative feedback equation for your transfer gain ratio with negative feedback. This is the expression we had derived, and for positive feedback you all had derived this particular expression, and I appreciate that. This was the block diagram that we had considered. Now going back to the negative feedback, because this is not more of positive feedback. Positive feedback we are going to study in the later half of the unit. As of now we are going to study negative feedback in detail. So what should be the change in this particular block diagram? There should be minus sign, which will tell you that it is negative feedback. Okay, now just have a look over here. There is xd is equal to xin. Okay, now this is fed to basic amplifier. This is the amplifier without any feedback. Okay, this block. Now the output signal that you are going to get will be multiplied with this gain, right? So it is going to be a into xin or a into xd, anything. Okay, so here you are going to get a into xd or a into xin. This is given to feedback network. So once it is given to feedback network, you are going to get the output as xf, which is going to be a xin multiplied by this beta. So you are going to get beta a xin or beta a xd, which is then given over here where there is minus sign, which means whatever you have got now over here is multiplied with minus 1 sign. Okay, so what is the final thing that comes up over here is beta x out is nothing but a xin. So beta a xin into minus 1. Okay. Now why I have told you all these things? The reason being that we are going to study a new parameter, that is loop gain or return ratio. Okay. This is what I have explained to you all. So you have xd or xn multiplied by a multiplied by beta multiplied by minus 1, which is going to be giving you minus beta a xd or xn. Okay. And this minus beta a is named as loop gain or return ratio. Fine. I hope this is clear to you all. Now, there is something known as return difference D. Okay. Now, return difference D is 1 minus of loop gain. Okay. So, 1 minus of what is loop gain? Loop gain is minus beta I. So, it is going to be 1 plus beta I. This is return difference parameter. Now, when we introduce feedback, we know that part of the output is given back, right? But how much is that part? Can I measure it? Okay, it is measured in decibels. Okay, and what is the formula for that? We need to consider the ratio of gain with feedback and gain without feedback. Okay, so you all can see over here, it is AF upon A, which is present. AF represents gain with feedback, A represents gain without feedback. Gain with feedback is also known as closed loop gain. Gain without feedback is also known as open loop gain. Okay, so please don't get confused when these terms are used. So to represent in dB, that is decibels, we have to take 20 log of this particular ratio. Fine. So 20 log to the base 10 AF. What is AF? AF we had found out long back for negative feedback we are doing. So it is A upon 1 plus beta A and upon this particular A. AA will get cancelled. Finally, you are going to get n is equal to 20 log to the base 10 1 upon 1 plus beta A. And this n value is going to be negative for negative feedback. Okay. So, this is a very important thing that you all should know. N will be negative number for negative feedback. Now, we have found out over here something, right? And we have got something beta A at the denominator. Okay, so what is the significance of those beta A that we are going to see now? A and beta are phasor quantities. Phasor quantities in the sense it will have both magnitude and phase. Okay, when I say magnitude and phase, it is having a number along with that of angle. Okay, so let me consider an amplifier stage wherein you give the input and you get the output with some phase shift, right? Like for example, common emitter amplifiers which we had studied in EDC 1, whenever we give input a sinusoid, say for example, output also you will get a sinusoid which will be 180 degree out of phase. Okay, I hope you all remember this. In common emitter amplifiers, it is always this way, right? We had seen for the practicals also. Now, say for example, there is a three-stage amplifier. Okay, there is a three-stage amplifier, then the total phase shift will be this 180 multiplied by 3, which is going to be 540. Now, what is the significance of 540 on unit circle? On unit circle, 540 meaning it is 180, another 180, so it becomes 360. What is 360 degree? Nothing but it comes back to 0. Okay, so it becomes 0. Then there is another 180 degree. So finally, the resultant of 540 degree is nothing but 180 degree, which tells me that beta usually has a phase value of 0 degree or 180 degree. 0 degree in the sense what? You give the input, you will get the output which is in phase with that of input. 180 degree signifies if you at all you give an input, you will get the output which is 180 degree out of phase with respect to input. Okay. So beta has these two values. So I can say that 1 minus beta is a complex quantity. Okay, this is a little bit of analysis on A and beta. Let's start with numericals. Let us read it. The voltage gain of the amplifier without feedback. Without feedback in the sense capital A is given to you as 3000. Calculate the voltage gain of the amplifier if negative feedback is introduced in the circuit, which means AF is asked. Given that feedback fraction M is equal to 0.01. Now what is this feedback fraction? It is basically beta. They will give you different symbols over here, but please note that whenever it is said feedback fraction, it is beta. Okay. So open loop voltage gain, as I told you all earlier, voltage gain without feedback is also named as open loop voltage gain. A is equal to 3000 given to you. What is asked is AF, and again I told you feedback fraction beta is given to you as 0.01. Use the formula, it's quite simple. AF is equal to A upon 1 plus beta A. Substitute, you're going to get some answer. Please note this and do check these answers. Okay, let's move to the next problem. Calculate the gain of negative feedback amplifier with an internal gain AV is equal to 75. Internal gain in the sense gain without feedback. Okay, they have given it as AV is equal to 75, and feedback fraction MV is equal to 1 upon 15. Feedback fraction in the sense it is nothing but beta, which is given to you. What will be the gain if AV doubles? Okay, this is the second part of the question. First part is to calculate a gain of negative feedback amplifier, which means AF. Okay, let's start. AV is given to you, that is open loop gain is given to you. Okay, A is equal to 75, AV and A are the same. Feedback fraction beta 1 upon 15, it's given to you. Voltage gain with negative feedback, AF is equal to A upon 1 plus beta A. This formula is clear to you all because we had derived it. Substitute, get the answer. Please do check these answers. Let's move to the next part of this question, that is what will happen if the AV doubles. What will happen to the gain if AV doubles? AV in the sense this open loop gain 75. If it becomes 75 into 2, doubles, right? So 75 into 2, that is 150. Let me name it as A dash. Okay. So in this particular formula, instead of A, I am going to substitute A dash. Beta remains the same. Okay. Substitute, check what you get. It's being observed that when AV doubles, you get slight increase in your feedback gain. Okay. That's it with this particular problem. Next problem. An amplifier has a voltage gain of 40. Okay. The amplifier is now modified to provide a 10% negative feedback. Here it is without feedback. Here it is with feedback now. Okay, in series with input. Calculate the voltage gain with feedback. Let's go part by part. First part is very easy. Okay, again A is given to you as 40. Beta is given to you as 10%. 10% in the sense it is 0.1. Okay, this formula you all are aware. Just substitute, get the answer. This serves your first part of the problem. Okay. Second part, amount of feedback in dB. Now in dB we had seen the formula in this video itself, in the beginning of this video. Okay. So we are going to use that formula. N is equal to 20 log to the base 10 1 upon 1 plus beta A. Okay. And we are supposed to find out, we are having beta and A with us. Just substitute, solve and get the answer. If you will notice, N is negative, which clearly tells you that it's a negative feedback. It's mentioned in the problem also, right? So it has to be negative. Fine. Moving to the last part of the problem, you have to find out loop gain. Now what is loop gain? We had seen again in the beginning of this video. Loop gain is given as minus beta A or minus A beta. Substitute, get the answer. Okay, please check all these answers. Okay, let's move to the next problem. The voltage gain of an amplifier without feedback is 2500. It's without feedback, so A is given to you as 2500. If 40 dB of negative feedback is added, what is the gain with feedback? And for obtaining the same output, how much must be the input increased? Okay, we are going to solve this part by part. First part is to find gain with feedback. Okay, A is given to you as 2500 and 40 dB of negative feedback, which means beta is given to you all in dB. Okay, now it is in dB. So what we need to do is that we need to use that N formula, which we usually use to calculate it in dB. Okay, because we need to make it unitless. Okay. So open loop gain A is equal to 2500. Okay. So I told you all n is equal to 20 log of 1 upon 1 plus beta a. This formula we need to make use of. Now what you are going to substitute n as? N is given over here as 40 dB. Okay. So 40 dB you are not going to substitute as 40 directly. You are going to substitute it as minus 40. Now why minus 40? Because it's a negative feedback. And for negative feedback it has to be negative. You cannot simply take this value and substitute. Okay. It has to be negative. Fine. So that is the reason you put minus 40 over here is equal to 20 log to the base 10 1 upon 1 plus beta a. Okay. Now solve this. How to solve this? This 20 will come down over here because it's multiplied. On the other side it will be divided. So it will be minus 40 upon 20. Log on one side taken to the other side will become anti-log. So it's going to be anti-log of minus 40 upon 20 1 upon 1 plus beta a. Now how to find anti-log? It is basically 10 raised to this particular value. Now why 10? Because log to the base 10. That is the reason you have to take 10 raised to minus 40 upon 20. If this was log to the base 2, then it would have been 2 raised to minus 40 upon 20. But as of now it is log to the base 10. So it's going to be 10 raised to minus 40 upon 20. So if I solve this, 10 raised to minus 40 upon 20 will be 10 raised to minus 2. Again I'll solve this. So I'll get finally 1 plus beta a is equal to 100. Okay. Just reverse this. This will be 10 raised to 2 then. Okay. So 1 plus beta a is 100. I'll keep it as it is because gain with feedback the formula is a upon 1 plus beta a. So a upon 1 plus beta a. So substitute 1 plus beta a as 100 directly. And what is a? Is 2500. Okay, so just substitute. So you'll get around 25. You can check it out. Now the next part of the problem is very important. For obtaining the same output, how much must be the input increase? Now this question itself is not so clear. Let me make it clear to you all. Now see, listen to this properly. Now say for example, I want to produce output of 5 volts by using the amplifier. Okay. And amplifier with feedback as well as without feedback, it should give me 5 volts. Now this is not possible if at all the input is the same in both the cases. Okay. So input should be changed. Now change to how much? In which case you are going to change? That is done considering the ratio of the gains. Okay. Let me be clear to you all. Now which ratio of the gains? It is amplifier without feedback, amplifier with feedback. Both these gains take a ratio of that. That is, you have 2500 upon 25 which you have found. So it's going to give you 100. Okay. So your input for same output should be 100 times the input without feedback. Okay. And that's how you get this particular ratio. Let's move to the next problem. An amplifier with negative feedback gives an output of 12.5 volts with input of 1.5 volts. Okay. So we know that gain, how do we measure? Usually gain is output upon input. So they have given me output voltage as well as the input voltage. This is with feedback. Okay. Now when feedback is removed, it requires 0.25 volts input for the same output. First question, find the value of the voltage gain without feedback and find beta. Okay, so these two things we are supposed to find out. We'll go step by step again. Okay, first we'll consider voltage gain without feedback. Without feedback is this. It requires this input. So V in is 0.25. Okay, for A is the voltage gain without feedback. But what is the output? Output is the same for same output as the amplifier with feedback. So it is 12.5 volts. Okay, so AV is equal to output voltage upon input voltage. Substitute, what is output voltage? It should be 12.5 upon input voltage for without feedback, it is 0.25. So solve this, check whether you all get this. Okay, let's move to the next part. that is with feedback, again output upon input. Okay, which is the output voltage for voltage gain with feedback? It gives the output voltage 12.5. What is the input voltage? With input voltage 1.5. So substitute and get the answer. Fine. Once this is done, now we need to get beta. Now beta is very simple to get because I have AVF, AF also I have, and A also I have. Okay, so use the formula A upon 1 plus beta A. Okay, only beta is unknown. Rearrange the terms, rearrange this particular formula itself, solve and get the answer. Please check all these answers. Now this is problem. These are the problems for practice which you are supposed to send me, and while sending me this time, please do make PDF and send it to me because there are too many problems. There are 5 problems which you need to solve. Okay, make a PDF and send it to me personally. I have referred only one book for this particular part. Thank you.